Hello students, welcome back to General Science digital class. In the previous video, we learnt heat, transfer of heat and ways of heat transfer, that are conduction, convection and radiation. Now, absorbers of heat radiations. The amount of heat which an object can absorb by radiation depends on the color of the object. The object having dark colors absorb more heat radiations than the object having light colors. There is an activity to show this. Take a black painted tin can and a white tin can of the same size. Pour equal amounts of water in both tin cans and fix thermometers in them with the help of rubber corks, as you can see in this picture. The initial temperature of water in both the tin cans are noted. Their initial temperatures will be exactly equal. Place both the tin cans in bright sunshine for 2 hours. After 2 hours, if we note the temperature of water in both the tin cans, we will find that water in black tin is at a higher temperature. It shows that a black object absorbs more heat radiations than a white object. Now, good and bad conductors of heat. Substances through which heat travels easily and quickly are said to be good conductors of heat. Metals are good conductors of heat, such as copper, gold, and aluminium. Examples of good conductors and bad conductors of heat you can see here in this picture. Substances through which heat travels very slowly are called bad conductors of heat. For example, wood, plastic, and cotton are not good conductors of heat energy. These are called insulators. That's why you can see in this picture, the wooden handle is a good insulator. The metal bodies is a good conductor of heat. The bodies of cookware are made up of metals and handles are made up of wood. Now, expansion and contraction of a solid substance due to heat. Metals expand on heating. There is an activity to show this. Take a metal ring and metal ball of such size that the ball just passes through the ring. Heat the ball and check whether it passes through the ring. Now let the ball cool and check whether it passes through the ring. We will observe when the ball is heated, it doesn't pass through the ring. And when the ball is cooled down, it passes again through the ring. This experiment shows that metals expand on heating and contract on cooling. That's why a small expansion of gaps are left along the rails to allow for expansion, as you can see in this picture. Expansion and contraction of liquids due to heat. There is an activity to show this. Fill a conical flask completely with water. Insert a glass tube and thermometer in 2 holes of the stopper and fit it to the conical flask, as you can see here in this picture. Heat the water and with the help of the ruler, record the water level in the glass tube after every 2 degrees Celsius rise in temperature. We will observe that when a liquid is heated, the distances between its particles increase and its volume too increases. This is called the expansion of liquids. When its temperature falls, the liquid contracts. Expansion and contraction of gases due to heat. There is an activity to understand this. Take a balloon and stretch the opening over the top of an empty bottle. Place the bottle in a container of hot water as you can see here in this picture. Placing a rock in the bottom of the bottle will help weigh it down. Wait a minute or so for the bottle to heat up. You will notice that as the air inside the bottle heats, the balloon begins to expand. This is because the air inside the bottle has expanded and its particles start moving faster. Now come to page number 62 of your textbook. See the box Great Scientists. Sir James Devere was a Scottish scientist. He made the first Thermos flask in 1892. That is why it is called Devere flask. Even today, a Devere flask is used for keeping a substance cold or hot. This is a double-walled flask. It consists of two glass tubes, one inside the other with the gap between them sealed. The surfaces of both the tubes are made shiny by a silver coating. The air between the two tubes is removed to create a vacuum. There is a protective jar of metal or plastic outside the tubes. For the protection of the flask, pieces of sponge or rubber are fixed between the outer jar and the flask. As you can see here in this picture, this is rubber support. And this white boundary you can see is vacuum. Also, there are two black colored springs. And this is silvered surface of the glass. Inside the flask there is liquid, and the outer boundary of this flask is made up of metal or plastic. When a hot substance is placed in a thermos flask, the heat going out gets reflected due to the shining surface of the inner tube. Hence, heat is not radiated. Neither conduction nor convection of the heat occurs because of the vacuum, as conduction and convection require medium. As a result, heat is not transferred to the outer cooler region and is retained inside for a long time. Hence, the liquid inside the flask remain hot or cold for a long time. Thank you, students. Now read the lesson thoroughly and mark the important points.